Good afternoon and welcome to part 3 of CIP design considerations. Good afternoon, Mark.
Hi, Yuki. How are you doing?
I'm doing well. One thing I want to talk about in this particular section is the role of functional specifications and how they lead and help to provide the roadmap for your process control integrator.
So the process engineer, when he designs a system, he's not only designing a system, but he has to make sure that it works, as he intended. So you would normally not only just have a functional specification, but you'd have flow paths where you actually take the P&ID and then you create these distinctive flow paths. And that's where you're able to find, the engineer finds some of his own mistakes for one, but then you write a functional specification, and that document is really detailed in fact that it tells every valve to get open, for how long will it get opened, and which instruments are in play, within the system, so that perhaps you're measuring temperature, which you should be. You have to make sure that you're giving the guidance to the ultimate programmer so he knows what to look for and what the tolerance are for temperature. And that this functional description or functional specification becomes very detailed, and it's absolutely, you're correct, it's a roadmap for them to do their integration controls with.
Absolutely, and it's going to be the foundation for your validation as well. And, once you've done all this engineering work, there comes a day when you finally get to install everything.
Mm-hmm.
And I think one of the things that's perhaps underrated is, the walk down of the system when it's first installed. So what is it that you look for when you're installing a process system?
So one of the things I would look for is to make sure that everything's sloped properly. You want everything returned back to the CIP skid. And usually that's either through an inductor or a return pump. And you want to make sure everything's sloped correctly to that direction. And then another thing is look for is dead legs. I know we've talked a little bit about dead legs in the past, but it's an easy mistake that installers frequently make and put the wrong size T's in, the wrong type of valves, and they end up with an excessive dead leg that just is not cleanable. That's another one. Valve install is another that I would look for. So each different type of valve requires that you install it in a specific way so that it doesn't have hold up. In a biofarm, for instance, diaphragm valves are really common. Diaphragm valves are very specific in how they need to be installed, to prevent water holdup within your system or fluid holdup. And others, and to make sure that your intent of your design has really been met. It's often common that the order of takeoffs that you have on a P&ID doesn't get translated correctly out in the field, and maybe they have one valve in one place where, as opposed to the order of takeoff, it was meant to be somewhere else, and that would throw off your flow paths and actually detour from your functional specification. So that's another that I would watch for.
No, absolutely. All important things before you start the system up and jump into cycle development. Why is cycle development an important process, an important part of all of this implementation?
So cycle development, this goes back a little bit to your TACT acronym, so it's a temperature, action, chemistry, and time, and that goes back to when you did a coupon study, hopefully with a chemical company, so that you determined how much of each of these different items that you needed to occur to be successful. So let's just say that one of your steps is a caustic wash. You want to make sure that your cycle development is defined in such a way that it's reaching the appropriate temperature that you want, and the appropriate caustic concentration. That's something that the process engineer will have a direct hand in. And you want to make certain that as all this is taking place, that you're not having any conflicting flow paths. That's another one to watch out for. And certainly there's a lot of little things to consider.
Absolutely, and all of that is, getting the bugs out of the system, making sure everything functions as appropriately so that you can have a successful right first time validation of your system and a reliable and trusted clean in place process for your manufacturing system.
So the fact that you mentioned validation, that's actually a very critical component, and this is where your group comes in. The validation department, your validation team, they're the ones that are going to set your criteria and your goals, your acceptance criteria for clean. Because what is clean? Clean is only whatever you define it to be. In a sterile system, clean is not sterile. So you want to make sure that you get it to the point to whatever that's defined or how that's defined. And, that would be through swab testing, microbes and a number of things, as you know. That's where you lean heavily on a validation team. And you want to make sure that they're involved in this from the start.
Absolutely. Collaborative teamwork is, I think, the successful path to a great conclusion for any project. So it's not just the validation people, it's not just the process people, it's not just the controls folks, but it's really everyone working in concert to make sure that we understand what the deliverables are up front, and so that you get the conclusion at the end that everyone wants and needs.
Oh, very critical. I completely agree.
Well, I really appreciate your time, and that wraps it up for us. I hope everyone learned something new today and feels free to reach out to Mark if they have any additional questions or want to follow up with a great project. Thank you again, Mark.
Yeah, thank you. It's been fun.